Yes. Definition of continuity. This is what definition says. A continuity of a function is a characteristic of that function and its functional value. A function is it's one of the character, okay, of a function, a very important fundamental character of a function. A function is considered continuous when its curve is continuous at every point within the domain and does not have any missing or breaking points with a certain interval or domain. So example for continuous function, as already give you a function, a trigonometric function which is having sine x is a continuous function. F of x is cos x, again I'm repeating, is a continuous function. And f of x, which is equal to x square, is a parabola, right? Parabola, you can complete the curve within the range without lifting the pen, right? How do you draw a parabola? You can write like this, right? Continuously you can write without lifting your pen if you know the curve, right? So there is no discontinuity. If this is a range, within that range and within the domain, there's no discontinuity. It might go extend infinitely, but there's no discontinuity within the curve, right? That is why it is also a continuous curve, right? So a straight line of the form f of x is equal to x plus 5. Within the given domain and range, it will be continuous if I fix the domain and range. Okay. So whereas discontinuous curve, just now I told you y is equal to tan x. There are many infinity will come at tan x, and also secant x, right? We know cos 0 is 1, whereas secant 0 is infinity, right? So this is discontinuous. We cannot draw secant of a function or secant of a x without lifting our pen. Similarly, cosecant x is a reciprocal of sine x, right? So sine 0 is 0, whereas cosecant 0 is infinity, right? So cos 0 is 1, so cos 90 is infinity. So we'll have, cos 9, what is cos 90? Cos 90 is 0 and secant 0 is going to be, secant 90 will be infinity. Sorry for that. Similarly, secant sine 0 is 0, so cosecant 0 will be infinity. So they are not defined in the range, so it will be infinite value, and we have to shift our pen while drawing their curve. That's why they are called discontinuous curves. Okay, so we'll come across many such function. Another famous example is f of x is like this. So we can define this as a greatest integer function. What is the greatest integer function? This function will only take integer values. Okay, so let me show the graph of this. If I say a greatest integer function, if I'm defining this function as greatest integer function, okay, so what does it say is you have to take only integral values in its range, okay, such that if you take f of 1, what is the greatest integer more than 1? What is the greatest integer less than 1 is 0. Okay. So similarly, f of 2, what is the greatest integer less than 2 is 1. Okay. Similarly, f of 1.5, if I take, so this will also take 1 only as an answer. Okay. If I plot the graph of this, for example, if I plot the graph of this function, let me name the numbers. Okay, this is 0, this is the x-axis, y-axis, this is 1, 2, 3, 4. I'm going to write that. So how this function works is f of 1 is 0, right? F of 1 will be 0, it will be here. And suddenly f of 2 will be, f of 1 is here, 0, whereas f of 2 will be here. Okay, so, and then f of 3 will be equal to, this is 1, this is 2. So if I say f of 3, the greatest integer less than 3 is 2. So anywhere from 2.1, 2.2, 2.3, any values you take, anything from 2 to 3, 2 to number less than 3, it will take the value, it will take an integer value, right? So it will be coming like this. So f of 2 will be 1, whereas the function is defined as greatest integer less than or equal to that number. For example, f of 2 will be 2, whereas anything from 2.5 to 3 will be this number. Again, it will be jumping here. So the graph will be going like this. So can you draw this? Imagine this graph. Can you draw this kind of graph without actually lifting your pen? Not possible at all, right? That's why it's a discontinuous curve. Okay. So let us understand the definition of this quickly now. So what does it say is if the following three conditions are met, then a function is considered to be continuous at x is equal to a in this domain. What is a here? A must be a part of the domain of the function, a number which is taken in the domain of the function. So a function is said to be continuous at a if f of x is following these three conditions. What is it? First, when you say f of x at x is equal to a should exist first. Exist means indirectly it has to be finite value. Okay. Secondly, the limit of, you know how to find the limit, right? So limit of this function f of x as x approaches to a exist. How do you mean by exist? Limit exist means indirectly when you limit that value, you need to get a finite value which is defined. At the same time, right hand limit as well as left hand limit. That is limit of this function as x approaches to a minus should be equal to limit of f of x as x approaches to a plus. That is right hand limit as well as left hand limit. Both should be equal to each other, and that should be a finite value. Okay. And finally, when you apply that limit should give you directly f of a. When you apply that limit, when limit of f of x as x approaches to a must be equal to f of a, then we say this is a technical way of understanding and proving the given function is continuous or not. But visually, if you want to say in a common language, if I say a function is continuous, it is simply if we can draw the curve without lifting the pen, that is a continuous curve within the given domain. That's what continuity is all about. Okay. Yes. Let's go to the questions. This we discussed already. This is where I was explaining. Now what we have to do is we have to understand the assertion and the reasoning, because it's assertion reasoning question and the options are all fixed. Okay, same options A, B, C, D. What is A saying is both assertion and reasoning are true, and reasoning is the correct explanation of A. And B says both A and R are true, and R is not the right explanation of A, or correct explanation of A. And C says A is true, but R is false, and D says A is false, R is true. Let's see first. Is this function sine x is continuous? Don't you see there are two functions involved in this? One is a modulus function or absolute value function, correct now? We are not going to write anything here because we need to know just the right option here, right? And second one is trigonometric function. What is that function? The trigonometric function is, what is that? Sine x. Okay, so let us assume f of x as mod x and g of x as sine x. Okay, now already we have discussed multiple times how the sine x looks like and what is the modulus function looks like. Let's see. Remember, next time if you want to plot the curve of a modulus function, this is how the function curve looks like. Okay, it's of the shape V shape, symmetric about the x and y axis. Okay. Okay, so now yes. So now what we have here is this is our this continues, I mean this curve continues towards infinity on either end. Okay, so now tell me Is it going to be drawn without lifting the pen? Yes, we can write. So that is continuous. That is this mod of, I mean, f of x is equal to mod x is continuous throughout the real numbers. Okay, in the domain of real numbers. And g of x, needless to say, I have multiple times mentioned, a sine curve is always a continuous function. So as this function is continuous and g of x is continuous, the combination of f of g of x, that is what we have modulus of sine x, is continuous in the range, in the domain of real numbers. That means assertion is true. If assertion is true, tell me which option I can eliminate directly. D option can be eliminated because D option is the only option which says assertion is false. So now we are left with three more options. So what is second one saying? Reason says sin x is continuous and mod x is also continuous in R. Yes, that is a reason. First assertion is true mainly because this part is true. That means both assertion and reasoning are true and R is a right explanation of A. That means option B is ruled out, option C is ruled out. The right answer is option A. Both A and R are true and R is the right explanation of A. I hope this is clear. Isn't it easy now? Does it make sense to you? Yes. Any questions? Anyone? Any doubts? Let me check if there is any question. I don't think any questions. Anybody has any doubt here so far? So can you respond if it is clear to you? Yes. Yes, 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 yes. I can see the response now. Let's go to the next one. Quickly, next question, which is question number 3. This is a very easy chapter if you understand like this. Now let's go to this question. As it's a multiple choice question, again, we don't have to do all the steps, but we can understand the approach to get the answer. How is the function defined is? A function, find the value of k. Where is k? There is k here. And the function is defined as f of x is equal to 3x plus 5 for x greater than or equal to 2. And k into x square if x is less than 2. And we want to find the value of k. So to find the value of k, we have to look at this point. Which point? The point where this has a this has a change in the value. That is, if it has to be continuous, then we need to look at the point where it can go discontinuous, where it is possibly discontinuous. We don't fix the value of k. Okay, that is at the point of x is equal to 2, right? So if I plot the curve of this, how does it look like? Without knowing k, I'm trying to plot the possible way the curve can look at. Okay, so this is 0. It's always good to understand the question with the graph. So if it is more than or equal to 2, it will be a straight line. Okay, but if it is less than 2, it might be a parabola, and the parabola is not properly defined. So it can be it depends clearly on the value of k now. Okay, let us assume some random value of k. So now I need to find out the value of k if it is continuous. If there is no shift in this part, at this place at k, it is not shifting, means what I need to do is f of x, applying the limit x approaches to 2 from the left hand side should be equal to what? Limit of f of x approaching from the right hand side, right? So this has to be equal, right? From the left hand side, if you're telling that is less than 2, the value will be k x square. From the right hand side, if it is more than or equal to 2, it is 3x plus 5, right? At what? At x is equal to 2. That's the point we are looking at. So that means in the place of x, we are going to replace that by 2. If this is continuous, this has to be true. 3 into 2 plus 5. So what we get is 4k is equal to 11. Then what is the value of k? 11 by 4. Now can you tell me which option is that? The option is which one? Option D, 11 by 4. Clearly option D. Please make a note of this if you have a doubt, and you can also look at the steps I have used and why am I using that, because I'm just following the rules of continuity discussed in the earlier part of this class. Okay, they have already mentioned it is continuous, and I need to find the point where it is continuous. That is also given. The possible point where it can be discontinuous is at 2. So if I make that point continuous by using the rules, applying the limit from the left hand side as well as the right hand side, if they're equal to each other at a particular point 2, I substitute the value of 2 in the place of x and find the value of k. If you replace this by 11 by 4, then only this will become continuous. Suppose if k is not equal to 11 by 4, what will happen is this curve will be having a discontinuity. It might jump to some other place. That is why this is the place where k must be equal to 11 by 4 so that the entire curve is continuous. Okay. I hope this makes sense, more sense now, right? So let us try to understand continuity with an example. How do we discuss continuity and what kind of questions we're expecting here? You can see this. Yes. Let me read the question to you. The question says, define the continuity of a function. Just a second. You can read the question meanwhile. Yeah, define the continuity of the function f, which is defined as f of x is equal to x plus 2 when x is less than or equal to 1 and x minus 2 if x is greater than 1. So that means there are two different regions we have to understand. One is if x is, 1 is a very critical point now. So if you're talking about x more than 1, the definition is f of x is equal to what? X minus 2. And if f of x is anywhere after that or below that, that is x less than or equal to 1, then what happens is it will become x plus 2. So what will happen? The graph is already here. So I will draw this again. Okay. So f of x is equal to x plus 2. If I talk about f of 2, it's going to be what? 2 plus 2. So f of 2, if it is 1 and 2, so at f of 1, it will be like this. The graph will be going like this. Okay. Whereas if you talk about, yeah, graph is here only, right? Already. So we'll discuss with this only. If you have a value less than 1, it will be going like this. So that means at 0, which is less than 1, the value of a function will be going through 2. Okay. The function goes like this. Okay. If you come after 1, which is going like this, that means this graph is actually, where is it continuous? It is not continuous at all, right? So there is a discontinuity. So by observation only, I can say it is discontinuous. But how do we prove that? And what are the steps we need to use to discuss this and prove that it is discontinuous is mentioned here. Say f of x is defined at all the points for all the real numbers. Is it correct? Is the first point correct? Yes, because whatever the real numbers you substitute here will definitely get a real value. There is no infinity here, right? Do you have any infinity here? No. So that means firstly it is defined for a given range and domain. Okay. So if c is less than 1, what happens? When c is less than 1, if you substitute f of c, which follows c plus 2. So that means if you apply the limit of x approaching to c for f of x, we will end up with x plus 2, or finally we get the value c plus 2. Whereas if c is greater than 1, we get c minus 2. Therefore, we can understand f of x as x approaches to x at c minus 2. So these two are not equal to each other. You see that if c is equal to 1, then the left hand limit is 1, whereas c is equal to more than 1. So what happens is we'll get a different answer, that's minus 1. So as these two values are not equal to each other, the right hand limit is not equal to left hand limit. So that means what is it? The function is not continuous at what point? 1. So it is not, I'm not telling you it's continuous at every point. It is not continuous which point? At 1. Because at 1 what is happening is the curve is jumping. Can you see that? So it was continuous curve here, and after this 1 also it is continuous, but at the point of 1 there is a discontinuity. Okay, that means what is the discontinuous place point? The point of discontinuity is what? 1. At 1 only it is discontinuous. So we are only discussing where it is discontinuous is at 1. Okay, so we are just understanding the continuity. The curve is continuous after 1 and before 1, but at 1 it is discontinuous. Okay, yes. Let's go to the next example. Yes. Let's solve some questions related to this concept. Okay, so now I want you to understand this function first. It's a greatest integer. Just now I discussed this as well. A greatest integer function which is less than or equal to x. So let us understand the function first and then try to plot the graph of this. So what is the greatest integer function? I already told you with an example. Function, greatest integer function, greatest integer less than or equal to. What do you mean by less than or equal to x? Can I define more than or equal to x? No. If I say greatest integer more than x, then f of 2 will be infinity, f of 3 will be infinity, f of anything will be infinity. Why? Because the greatest integer more than anything will go to greatest number is going to be infinity. That's why they're using the word greatest integer less than or equal to x. What do you mean by that? For example, if you are talking about 2, what is the greatest integer less than or equal to 2? 2 itself. You cannot go beyond that, right? So if I say 2.1, that is also 2 only, because the integer lesser than 2, but the greatest integer is 2 itself, right? So it will go on like this till what number? Till you go to the next integer, that is 2.999, it will be still 2 only. But if you talk about f of 3, it is an integer, and the greatest integer less than or equal to 3 is 3, right? So let me plot the curve of graph of this quickly. Yes. So do we have a point of discontinuity? Yes, we have a point of discontinuity for this curve, definitely, because your graph is going to be shifting, right? So this is 0. This is 1, 2, 3, 4, 5. So this is x-axis, this is y-axis. So at 0, what is the value? What is f of 0? 0 itself, right? So what is f of 0.1? 0 itself. So let me talk about 1 now. At 1, the value is 0, right? Till what number? It will be here, and it will be discontinuous 2. At 2, it will be 2, and I mean this dot is included, this hollow circle is excluded. So it will be like this. It is also called as a step function, okay? So we don't want to get into technical names for all this. But you see this curve, if you see, you cannot plot this curve without shifting the graph. Am I right? Yes. So without shifting the pen, you cannot plot this curve at all. So that means it is discontinuous, right? So what is the question? In these options, you have to discuss the function f of x, which is greatest integer less than or equal to x, is continuous at. Now tell me where it is continuous, where it is discontinuous. It is discontinuous at all the integers. Can you see? At 2, it is discontinuous because it is moving from this to this. There is a discontinuity. At 1, it is discontinuous. At 3, it is discontinuous. At 4, it is discontinuous. At 5, it is discontinuous. That means every integer it's going to be discontinuous. And where it is continuous, every fraction or every non-integer number, it will be continuous, right? That means in the option, there is only one fraction at 1.5. Here it is C at 1.5 is the point here, and it is continuous here. Whereas at this point, by looking at the graph only, I can say this is continuous at this point. Whereas if you talk about 1, if you apply the limit of this function, x approaches to 1 from the left side is different. I can prove that also. As is a multiple choice question, you don't have to prove also. But if you want to prove, see, f of x at x approaches from -1. If you're starting from -1 side, I mean 1 from the negative end, it will be giving you what value? 0. From the positive end, if you go for 1, so that means the right hand limit is not equal to left hand limit at all the integers, not just 1, at all integers, right? Whereas at a fraction, it will be continuous. That's why the answer is option B. Let's see how they have explained this answer, shall we? Shall we explain? Shall we check the explanation? And is it in line with our solution? Okay, this explanation is not here. So as it's a multiple choice question, the answer should be taken directly. It's not given here. The answer is simply option B, which is 1.5. Okay, so just make a note of this example. And next time, whenever you see a greatest integer function, this should be in your mind. This is how the function looks like. Okay, yes. So let's go to the next question quickly. Yes. Meanwhile, any questions, any doubts from anybody? Let me check. Anybody has any questions? Is the concept clear to all of you? When I say algebra, it's all about operations. Algebra means we are talking about algebra of real numbers, algebra of rational numbers. Similarly, we are talking about algebra of functions. That is addition, subtraction, multiplication, and division, how it works in the function. So if f of x is a continuous function, f of x is a continuous function at a particular real number in its domain at C, and g of x is also continuous at C, then we can say f of x plus g of x is also first point continuous at where? At the defined point C. Similarly, I can say its difference is also continuous at C. I can also say the product of these two functions will also be continuous at C. And finally, we can say the division or the fraction is also continuous at C, provided very important condition, g of x is not equal to 0 at C. Okay, instead of writing at C, they are told directly f of g is continuous at C. So I can say f of c plus g of c exist because its left hand limit and right hand limit are equal to each other, and this exists. Okay, similarly difference exists and the product exists and the ratio exists provided g of c is not equal to 0. Can you tell me why g of c should not be equal to 0? Because whatever is there at the denominator, if the 0 is there at the denominator, what will happen is our value will be indefinite, right? Yes. That's all about the algebra of these functions. Let's take an example to make it easy. Okay. Proof of this continuity is explained here. Just have a look at it. Okay. So this is coming from our limits chapter. In the limits, we are discussing algebra of limits. Okay. So checking the continuity of f of g, f plus g at x is equal to c. So since x is equal to c is a function is defined at c, we can say limit of x approaches to c is equal to limit of x up to c, sum of these two, because they are continuous functions. So this is how we are proving that. So you can check the proof of this part. Okay, as the limit exists at the addition, even they are continuous after adding the values. Okay, similar proof can be used for addition, subtraction, division, as well as multiplication, provided the denominator is not equal to 0. Okay, there's one more theorem that is talking about composite functions. What do you mean by composite functions? Let me take an example. F of x is equal to x square and g of x is equal to x plus 2. Now, if I want f of g of x, that is composite function. So first what will I do is, in the place of g of x, I'll get the value of that. Okay, and in the place of x we have x plus 2. So if you say f of x is x square, what is f of x plus 2? Which is x plus 2 whole square. So this is symbolically written as f of g of x, which is actually in this case x plus 2 whole square. Similarly, if I want in the other order, g of f of x, which can also be written as g of f of x. So what will you do now? So first you will substitute the value of f of x. Okay, and in the place of x we have x square, so it will become x square plus 2. Okay, this is composite function, which is symbolically written like this, right? Now, what are we discussing here is, suppose if f and g are real valued functions such that f of g is defined at C. It's very, very important. We cannot leave this point. If it is defined only, we'll discuss about its continuity. Then if g of x is continuous at C and f of x is also continuous at G, then I can say f of g is also continuous at C. Okay, so f of, not just that, f of g is continuous at C, at the same time g of f is also continuous at C. Okay, not only this order, we can also say g of f is also continuous at C. Okay, these are the theorems which is not being asked for us, but we need to know them so that we can prove some questions, right, with the help of this theorem. Okay, so let us see how can we use them in our problems. Okay, let's look at some examples of what I thought right now. So there is a function here. Show the continuity of sine function. As I told you already, graph of sine function. Let me redraw that graph again. It's not a problem at all. Until we learn the concept, we can draw the curve any number of times. Okay. How the sine curve looks like is, if this is -1, this is +1, at 0 it is 0, this is pi by 2, this is pi, 3 pi by 2, 2 pi, this side I'll go for minus pi by 2, minus pi. These are nothing but angles, right? It can go till what? Infinity, right? So our curve will be like this. It is why this is called sinusoidal curve. It's a periodic curve, and you might have seen this curve already in your physics, right? Oscillation of a pendulum is a sinusoidal curve. So you don't have, I don't have to explain you the application of all these things. You already come across all these things, right? So right now, let me understand the continuity of this function. Pictorially, I can say this is continuous throughout its range and domain, right? But whereas theoretically, how to prove that is, so they are given the function, we have taken the function as it is, and we are trying to approach the limit from the left hand side. Limit of x approaches to C minus. Okay, where what is C? C belongs to its domain. Okay, what is the domain of this function is all the real numbers. Whatever the angle you put, it's in the form of a real numbers starting from -infinity to +infinity. Okay, C is a number which is between -infinity to +infinity. Then what happens is, can you show me the range of this function? What is the highest value it is taking and the lowest value it is taking is -1 to +1. Okay, so my answer to this function will always lie between -1 to +1. That's the range. Whereas domain, it is going from -infinity on the x side, left hand side of the x-axis, and +infinity on the right side of the x-axis. Now, how do you understand the limit of this is, if you want to apply? So this is nothing but what? Left hand limit, right? So C is a random number in this real numbers. Left hand limit and right hand limit both are equal to C. That's first thing. That's their checking if it is true or not. The left hand limit is taken as limit of x approaches to C minus sine x is equal to limit of h approaches to 0 sine of C minus h. That is, you are going to subtract 1 from the left hand side, okay, and you are moving towards that by making h approaches 0. Okay, it is same as this, right? Similarly, if you want to go for right hand limit, you'll go for C plus, that is from the right hand side of this function sine of x, which can also be equal to h approaches to 0 sine of what? X C plus h. Okay, so which is same. So by putting h is equal to 0 in both the cases, we get sine C. That is the reason f of x is equal to sine x exists at C. That means the function is first defined there at that point, right? And left hand limit as well as the right hand limit both are equal to sine C, right? So that is the reason the curve is what? Continuous, and the function is also defined continuous throughout its range. Okay. So now we have another question. So I hope this explanation is clear to you. Okay, so this is how the step-by-step process you have to follow if you're discussing the continuity of a function, if it's a question which is asked in the subjective part. Okay, so let me go to the next question. Right, now how are we going to prove this? Are we going to use all these steps, or are we going to have any shortcut for this? So there is a function now. The function is like this: f of x is equal to sine of x square. Can I call it as, let me name this as not f of x, let me name it as g of x or h of x. Okay, let us say this x square in the bracket be g of x. Okay, and f of x be sine x. Now, don't you see this is f of g of x, right? That is f of sine, f of x square, which will become sine x square. So tell me what kind of function it is. What kind of function it is? It is a composite function, isn't it? It's a composite function. So now if I have to prove the composite function is continuous in a given domain, what are the points I need to know? First, f of x is continuous. I should prove at the given domain. Okay. Similarly, g of x is also continuous at the given domain. I need to prove that. So once I'm able to prove g of x and f of x is continuous, definitely g of f of x and f of g of x is also going to be continuous in the given range. So shall we understand that it's not proved here, but we can just theoretically or with a graph we can understand are they continuous or not. Firstly, let me erase this. We know if I define f of x is sine x, already I told you the graph of that. So what is this g of x now, which is x square? What is the graph of this? It's a parabola passing through 0 and with the axis of symmetry as y-axis, right? That is what f of x is, g of x is equal to x square. Isn't it continuous throughout the infinite, throughout the real numbers? Yes, it is a continuous function. And sine x is also, as I told you again repeatedly, this is the curve and which is continuous throughout the curve. So as I know, g of sine x is continuous and x square is also continuous. Sine of x square is also going to be continuous. Okay, it is just a discussion. If you want to prove all this, you have to separately prove like this for sine of x, which is already proved here. And similarly, all the steps you can follow to prove f of x is g of x is equal to x square is also continuous. And using the theorem which says if f of x and g of x are continuous in a given range at C, then g of f of x is also going to be continuous in a given range or domain. Okay. So let us see, the theory part is always something which you have to be very careful. Every step-by-step explanation has to be given. Okay, or you can compare with these examples and say, use the theorem and say because g of x is continuous and h of x, f of x is also continuous, their composition is also going to be continuous in the given domain. Okay,